Hi guys, today we are going to introduce our third and final technique to solve quadratic equations. We are going to solve quadratic equations by using the quadratic formula. The quadratic formula says this: if this is your question, then this is your answer. So I want to point out that in this case we have an equation, a degree 2 equation, and the variable is x. A, B, C are just numbers. So in this case we're solving for x. So that's why the reasons for that reason, the quadratic formula says this: if this is your question, this is your answer. And we have x equals, because we're solving for x. So the answer is x equals opposite b plus or minus the square root of b squared minus 4ac, and that's all over 2a. The toughest part about solving a quadratic equation by using the quadratic formula is remembering the formula itself. The next toughest part is just for you to keep your cool and not make an arithmetic mistake. Before we solve our first equation by using this technique though, I want to talk about the discriminant. The discriminant, what is that? The discriminant, denoted by the lowercase d, is just the radicand in the quadratic formula. So let me just go ahead circle that. So the discriminant is given by the radicand in the quadratic formula. The reason why we give special attention to the discriminant is because the discriminant tells us how many solutions and the types of solutions that we're expected to have. If the discriminant is positive, negative, or 0, that will tell us how many solutions and the kinds of solutions that we're going to have. Okay, so let's go ahead and do this. So for this, these next 3 fun problems, I'm not really interested in the solution. The problem reads: find the discriminant and use it to predict the number and types of solutions. So tell me what the discriminant is, and then make a prediction to tell me how many solutions are we expected to have and what kinds of solutions. Are they real number solutions, non-real solutions, and so forth. Okay, so let's go ahead, pretend we're gonna solve it. So the first thing we need to do, if we were gonna solve it by using the quadratic formula, is to write it in standard form, or in English, set the equation equal to 0. So let's go ahead, set it equal to 0. So we're going to go ahead, add 1 to both sides, and that will leave us with x squared minus 4x plus 1 equals 0. Fantastic. So remember, we're not trying to, I'm not interested in the solution. I want to know what the discriminant is. For me, it's really tough to remember this formula, d equals b squared minus 4ac. I can only remember so many things at once. But what I can remember is the quadratic formula. So the quadratic formula says this: x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. I know you like my singing, don't pretend like you don't. Alright, so yeah, I was singing that to the tune of Pop Goes the Weasel. You know that song that everyone knows the melody to, but they don't know the words? Yeah, that one. Okay, let's do this. So the discriminant, okay, what is that? The discriminant is code for the radicand in the quadratic formula. Sorry, it's hard for me to write, speak, and spell all at the same time. Okay, so let me go ahead and write out the formula. The discriminant equals b squared minus 4ac. Whenever I am asked to find the discriminant, I'll always write down the quadratic formula, and then with confidence I'll nail the discriminant. Let's go ahead and identify our values for a, b, and c. Leading coefficient is 1, that's our a. Coefficient of the middle term is -4, that's our b. Constant term is 1. So that's our C. So let's go ahead, plug and chug. So the discriminant equals b squared. Value of b is -4, but we have to square it, minus 4 times a, which is 1, times c. I always use both of my hands, one to write and the other one to point. So at this point, it's strictly arithmetic, so punch it in your calculator, but I don't have a calculator, so I have to freehand it. The square of -4 is 16, and the product of 4, 1, and 1 is a 4, and that will give us the discriminant is 12. So that is our first answer. The first question is, tell me what the discriminant is. Then I need you to use it to tell me how many solutions, and then what kinds of solutions are we expected to have. Now, I can make this easy on myself and just say this: if the discriminant is positive, boom. But I'm trying to convey to you why is it that we are going to write what we're going to write. So we have that the solution will be x equals -b plus or minus the square root of b squared minus 4ac. But we just told the reader that b squared minus 4ac simplifies to 12, and that's all over 2a. So again, I'm not trying to solve it, so that's why I'm not substituting the values for b and a. So I know that you know that the square root of 12, I'm like, is it a real number or is it a non-real number? Okay, since the discriminant is a positive number, okay, that means that square root of 12 is a real number. Okay, now before we go straight to the answer, let's break it down. What would the solutions look like? So the formula reads x equals negative b plus or minus the square root of this bad boy all over 2a. So this is how it's gonna go down. The first solution is negative b plus the square root of 12. That's the number 1. Yeah, sorry for that ink. Okay, the second solution, negative b minus the square root of 12. Okay, so we're gonna have two solutions. So we're gonna have two solutions. What kinds of solutions? The discriminant is positive, so that means that's gonna give us a real number. So we're gonna have two real number solutions, or just two real solutions. Fantastic. Okay, that was too many wording. Then just let's look at what the book does. It says if the discriminant is positive, then the equation has two real solutions. Do what you gotta do. Okay, let's go ahead and look at problem B. So lucky for us, it's already a set equal to 0, so I'm going to go ahead and write down the discriminant. I don't have the space to write down the quadratic formula every time, so we wrote it once, so let's go ahead and copy it over. Okay, so we have that the discriminant equals b squared minus 4ac, and let's go ahead and do the math. Leading coefficient once again is 1, so that's our a. Coefficient of the middle term is negative 2, that's our b. Constant term is also 2, so that's our c. Let's go ahead, plug and chug. So we have d equals b squared. Value of b is negative 2. We got to square it. Minus 4 times a, which is 1, times c, which is 2. Again, you have a calculator, punch it in, but I have to freehand it because I misplaced my calculator. The square of negative 2 is 4. Product of 4, 1, and 2 is, where am I, 8. And then that difference is negative 4. So that's our first solution. Now we want to use the discriminant to tell the reader how many solutions and what kind of solutions are we expected to have. So from the quadratic formula, we have that x equals opposite b plus or minus the square root of b squared minus 4ac. But we just found out that b squared minus 4ac is negative 4. And that's all over 2a. So let's go ahead and point out the facts. So I want to ask myself, is the discriminant positive, negative, 0? So the discriminant is negative. Okay, so in this case, the square root of negative 4 is going to represent a not a real number. Okay. Why is it not a real number? Because we're square rooting a negative number. So the question is, how many solutions are we going to have? So we have x equals negative b plus or minus the square root of negative 4 all over 2a. So let's do this. Solution number 1, negative b plus the radical. Cool. Solution number 2, negative b minus the radical. So we're expected to have two solutions. What kinds of solutions? Real number or non-real numbers? Because the discriminant is negative, that's going to give us a non-real solution. So how many? 2 of them. So we're going to write down 2 non-real solutions. You may also write 2 imaginary solutions. Whatever word you use in class, that's what I need you to write. Okay. Alright, for the grand finale, problem C, before we actually start to solve our first equation. So let's go ahead and find the discriminant and then use it to predict how many solutions and what kinds of solutions. Real, non-real. Let's do this. First things first, we need to set this equal to 0. If we don't, then we can't identify values for A, B, and C because the equation has to be in standard form or set equal to 0. So that will leave us with x squared minus 4x plus 4 is equal to 0. Take your time, identify what you need. Leading coefficient is 1, that's our A. Coefficient of the middle term is negative 4, that's our C. Coefficient of the middle term is negative 4, that's our B. Constant term is 4, so that's our C. We wrote down the quadratic formula once, and then with confidence we can identify the discriminant, which is code for the radicand in the quadratic formula. So we have that the discriminant, or D, equals b squared minus 4ac. So let's do this. So we have discriminant equals b squared, so that will be the square of negative 4 minus 4 times a, which is 1, times c, which is 4. So we have that the discriminant is, where am I? Square negative 4 is 16. Product of 4, 1, and 4 is 16. And the difference of 16 and itself will give us 0. Cool. Alright, so the question is, using the discriminant, how many solutions and what kinds of solutions are we expected to have? So from the quadratic formula, we have x equals opposite b plus or minus the square root of b squared minus 4ac, which we said is 0, and that's all over 2a. So the first thing I want to ask myself is this: is the discriminant positive? Is the discriminant negative? In this case, it's neither one, because 0 is neither positive nor negative. So we're just going to say that the discriminant is 0. Okay, so now that the discriminant, given that the discriminant is 0, how many solutions and what kinds of solutions are we expected to have? So the square root of 0 is a real number. Okay, so we are going to have real number solutions. Cool. But now the question is, how many real number solutions are we expected to have? Well, I know that you know that the square root of 0 evaluates to 0. Okay, so this is what I'm technically supposed to say. Solution number 1, negative b plus 0. Solution number 2, negative b minus 0. But check it out. Negative b plus 0 is the same as negative b minus 0. So we're not going to have two solutions. We're just going to have one solution, and it's a real number solution. So the moral of the story is this: if your discriminant is positive, then you're going to have two real solutions. If your discriminant is negative, then you're going to have two non-real solutions. And if the discriminant is 0, then you're going to have one real solution. Fantastic. So now what are we going to do? We are going to finally use the quadratic formula to solve not one but two quadratic equations. Let me find my problem. Found it. Look at me, I'm so organized. Cool. Alright, so I think this is like an old page. This was my original setup, and I'm not gonna edit this video. Okay, so we are gonna solve quadratic equations by using the quadratic formula. This is what happens when you don't proofread your notes. Okay, so it says solve each equation. So what I want to point out is this: it doesn't say what technique to use, so it's a personal choice. So let's do this. Let me go ahead, write down the problem. Problem A, we have 3x squared is equal to 8 minus 10x. Fantastic. So given that it doesn't say what technique to use, I'm gonna pretend like I'm taking the final. So what I would ask myself is this: can I take a shortcut? Can I use the square root method? Okay, in this case the answer is no, because of this x term. So then I'm gonna ask myself, is this factorable? I mean, if you want to go straight to quadratic formula, go for it. Okay, but I'm like, this is how I approach it. Is it factorable? So I'm just gonna assume that it is until I realize that it's not. So to solve by factoring, let's go ahead, set this equal to 0, so that we will add 10x to both sides, and that will give us 3x squared plus 10x is equal to 8. It's not quite set equal to 0, so let's go ahead, continue our magic. We will subtract 8 from both sides, and that will give us 3x squared plus 10x minus 8 is equal to 0. So now the question is this factorable? So I don't know. So we're going to go ahead, use the AC method. This is not my go-to method, but it's the method that I think will work for most people. Okay, so the AC method, the gist of the AC method is to split the middle term into two terms. So we can have not 3 but 4 terms, and then factor by grouping. So the AC method, we want factors of AC that add up to B. So this is a trinomial of the form ax squared plus bx plus c. So leading coefficient is 3, so that's our A. Coefficient of the middle term is 10, that's our B. Constant term is -8, so that's our C. So let's do this. We want factors of AC that add up to B. Product of 3 and -8 is -24, and the value of B is 10. So we think about it. Factors of -24, if you need a gentle reminder, you put a times and a plus. Factors of -24 that add up to 10, is it 12 and 2? Yeah, I shouldn't whisper, but sorry that I was thinking. I'm supposed to think out loud like they do in reality shows. I don't know how they do that. Okay, so product of 12 and 2 is 24, but I need the larger factor to be positive. So in this case, it's going to be 12 and -2. So again, the gist of the AC method is to split the middle term, so we can have 4 terms and then factor by grouping. So we're going to take our sides and tag along the variable part of the middle term. So let's do this. So this will give us 3x squared, and we will replace 10x by the sides. So 12 is positive, so we're going to put plus 12x. 2 is negative, that's how we put minus 2x, and we bring down the rest of the problem. Bear in mind, we can always we can always rewrite whatever we have. We just can't change its meaning. 12x minus 2x gives us 10x, so it's the same problem, just phrased a little bit different. So now let's go ahead factor by grouping. So we're going to group the first 2 terms and then the last 2 terms. When we look at the first group, 3x squared and 12x have a common factor of 3x, so let's do this, and that will leave us with x plus 4. And if you're a little iffy, you can just check it. I know that you know that 2x and 8 have a common factor of 2, but what I like to tell students is this: when you take out a common factor, fix it so the first term you're left with is positive. Who cares if the rest is negative? So for that reason, we're going to factor out a -2. When we do, -2x divided by -2 will give us x, and -8 divided by -2 will give us 4. Now, it is no coincidence that the binomial factors match. They're supposed to match. If they don't, then your x game is wrong. So go ahead and check it. So to continue the factoring process, let's go ahead and factor out the common binomial factor of x plus 4. So let's go ahead and show the reader what we're left with after we factored from the expression. First product over common factor, the x plus 4's cancel, and that will leave you with 3x. Second product over common factor, the binomials cancel out, and that will leave you with -2. Cool, let's go ahead and bring down the rest of the equation. Cool. So now that we have factored, let's go ahead and apply the zero factor property and set each factor equal to each other. So if a product equals 0, then there's no way you're around it. One of those factors has to equal 0. Either the first factor equals 0 or the second factor equals 0. If the first factor equals 0, that's going to give us a -4. If the second factor equals 0, after we add 2 to both sides and divide both sides by 3, that will give us a 2/3. So we have that one solution is -4 and another solution is 2/3. Cool. So under normal circumstances, we do the problem once and then move on. But we're actually going to do this problem again using the technique of this video. We're going to do it again by using the quadratic formula, and we should get the same answer, else I'm going to have a situation. So I'm going to do this problem one more time, but I don't want to call it problem B. I'm going to call it A2 because I want to emphasize that it's the same problem but done again. Okay, so we have 3x squared is equal to 8 minus 10x. So the question is, how do we solve a quadratic equation by using quadratic formula? The first thing we need to do is set the equation equal to 0. So same speech, we add 10x to both sides, and once we do, sorry, I can't get ahead of myself too much. So in order to solve a quadratic equation by using the quadratic formula, let's go ahead work our magic to set it equal to 0. So we will add 10x to both sides, and then whenever we're ready, we'll subtract 8, and that will give us 3x squared plus 10x minus 8 is equal to 0. Fantastic. So again, we're not going to continue the factoring process. We want to use a quadratic formula. So far, it took me like the same amount of space. Cool. So the quadratic formula says this. If this is your question, then this is your answer. So we have x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. I know I don't have the best voice, and it's okay. Good thing I already passed this class. So let's do this. So we nailed the quadratic formula. Cool. Let's identify the values for a, b, and c. Not because we have to, it just brings us peace of mind. So leading coefficient is our a, coefficient of the middle term is b, constant term is c. You got a calculator, so help me punch it in. So we have x equals opposite b, value of b is 10, and then we're going to add or subtract the square root of b squared. B is 10. We have to square it, minus 4 times a. A is 3, and where am I? C is negative 8. Fantastic. Okay, so let's do this, and that's all over to a. Oh, a is what? A is 3. This is what happens when I put my other hand down. Okay, so yeah, so that will give us x equals negative 10 plus or minus. At this point, this is arithmetic, so if you have easy access to your calculator, then go ahead, punch it in. But I don't have easy access to mine, so I'm going to try to do it by hand. Okay, the square of 10 is 100. Negative times negative is a positive. Cool. Product of 4 and 3 is 12, and if I know my 12 times table, 12 times 8 is 96, and we have established that the product is positive. Product of 2 and 3 is 6, so that will give us a negative 10 plus or minus the square root of 196 all over 6. So I had said that I had misplaced my calculator. Just kidding, I found it right now. Okay, so we have x equals negative 10 plus or minus the square root of 196, which I'm not going to try to do by hand. So the calculator gives us 14, I believe, if I did it right. Okay, I'll find out right now because we have to get the same answer. So let's go ahead, split this, write it without the plus or minus. So one solution is given by negative 10 plus 14 divided by 6, and another solution is given by negative 10 minus 14 divided by 6. So let's do this. Sum of negative 10 and 14 will give us 4. I think it's 4. Difference of negative 10 and 14 is negative 24. Last time I checked, 4 over 6 reduces to 2 over 3, or 2/3. And quotient of negative 24 and 6 is negative 4. Now, a lot of students favor this technique, but I don't really use this technique unless I have no choice. Why? Because quadratic formula is nice. I mean, don't get me wrong, I'm not anti-quadratic formula, but the thing is, it's very heavy computation. It just takes like one negative for this to get ugly real quick. But either way, I wanted to point out that it was the same problem, so we need to get the same answer, negative 4 and 2/3. Cool. So we're going to go ahead and do just one more equation. We're only going to do it once because we don't have time to do it twice. Okay, bear with me. Okay, so for the grand finale, so we are asked to solve x squared plus 3 equals 2x. We have a degree 2 equation or a quadratic equation. So for me, I would like to ask myself, can I take a shortcut? Can I use the square root method? And the answer is no, because of this loose x. So then I'm going to ask myself, is this factorable? So let me write it out. Okay, so is this factorable? I'm not sure if I wrote that question on the previous problem, but let's do this. So you know my speech. I'm going to assume that it is until I realize that it's not. So we have x squared minus 2x plus 3 is equal to 0. So a moment of the hour, does the x game have a solution? So we want factors of c that add up to b, factors of 3 that add up to negative 2. 3 is prime, so 1 and 3 has to work. No, it's not gonna work. No, because both will have to be negative. So since the x game doesn't have a solution, then the trinomial is not factorable. If the x game had a solution, then the trinomial would be factorable, but that's not the case. So we have some options. If it's not factorable, you can complete the square, or you can use quadratic formula. A lot of students don't like to complete the square, so I'm going to give the people what they want. We're going to solve by using quadratic formula. So for the last time, you could sing with me. Sorry. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Oh my gosh, I know my voice is terrible, but it's not as terrible as it sounds right now. But I've been speaking for a really long time, so I need to, like, what's the saying in English? Wet my whistle? Yeah, whatever. Remind me not to say no more English sayings. Okay, cool. So we have the quadratic formula nailed. We just got to identify a, b, c. Well, you don't have to identify values for a, b, and c for credit, but I do it for my peace of mind. Okay, formula is nailed. ABC is identified. We are going to promise not to make a careless mistake. Let's get our full credit. So we have x equals opposite b, so we have a negative sign, and the value of b is -2, and then we're going to add or subtract the square root of b squared. Value of b is -2. Let's go ahead and square it. Minus 4 times a is 1, times c. So don't forget to pause and rewind as many times as you want. Okay, and that's all over 2a. Okay, let me zoom in. That's all over 2a. Value of a is 1. We did it. We have the formula nailed. I think we substituted everything correctly. You have a calculator. Use it. So that will give us x equals opposite of -2 is +2. And then we're going to add or subtract. And if you have a calculator, just punch it in. I don't, so I'm going to freehand it. The square of -2 is 4. Minus product of 4, 1, and 3 is 12. And that's all over 2. Fantastic. Difference of 4 and 12 will give us, what is that again? 8, but -8. And that's all over 2. So if you can simplify the square root of -8 in your head, go for it. But I sincerely can't, so I'm going to do it on the side. When it comes to simplifying square roots of negative numbers, the first thing we want to do is fix it so the radicand is positive. So we are going to replace the square root of -1 with the imaginary unit I, and then multiply it by the leftover radical, which is square root of 8. So 8 has a perfect square, namely 4. So we're going to write that as square root of 4 times square root of 2. You keep your cool. The square root of 4 simplifies to 2, and that will give us that I times 2, or 2i, and multiplied by the square root of 2. Sorry, I had a little situation. Alright, so let's bring it together. So we have x equals 2 plus or minus whatever the square root of -8 simplifies to. And our hard work, whether we went straight to answer or we freehanded, gives us 2i square root of 2. 2i square root of 2, and that's all over 2. Cool. Alright, so let's go ahead. Because we have a non-real solution, there's an I involved. Let's go ahead, put this in standard form for a non-real number, a plus bi. So we want to separate the real part from the pure imaginary part. So the first term that we have is 2. What's going on with the 2? Fraction bar. So let's divide it by the denominator of 2. The operation, we're going to add or subtract the next term, which is 2i root 2. What's going on with that term? We have the fraction bar, so let's also go ahead, divide it by the denominator of 2. Real part is separated from the pure imaginary part, so we're good. Let's go ahead, reduce it now, and then we'll write it without the plus or minus. Quotient of 2 in itself will give us 1, so that will leave us with 1. Plus or minus quotient of 2 in itself will give us I square root of 2. Fantastic. So that's it. Let's just get our full credit and write our answer without the plus or minus. So one solution should read 1 plus I times the square root of 2, and another solution should read I times the sorry, and the other solution should read 1 minus I times the square root of 2. Okay guys, we did it. Thanks.